Hello everyone, hope you are doing good. I will discuss about solid principles. These are the five. Solid is a five letters. These are divided into five principles. Single responsibility principle, open and close principle, Disco substitution principle, interface aggregation principle, fifth one, dependency inversion principle. What are the solid principles? Solid principles are five. Solid is a five letter, so these are divided into five principles. First principle is single responsibility principle, open and close principle, it's called substitution principle, interface aggregation principle, dependency inversion principle. I will show each principle, one bad practice and good practice examples. Single responsibility principle. A class should have only one region to change. What is saying? Single responsibility principle, one region to change. So this is the bad practice. This is the good practice. See here, employee class is there. I am adding in employee class, add employee and add address. So it is the violating the single responsibility principle. Why? Because only single region to change. But I have two regions. So one region is employee, one region is address. So one reason to change employee, one reason to change address. So it is violating the single responsibility principle. A class should have only one reason to change, but we have two reason to change because employee is the one reason to change, address is the one reason to change. Instead of adding single class employee logic and address logic, it is separate the one employee class, right? Add a employee separate address class, add address logic. So it is satisfying the single responsibility principle. So it is not violating anything. So if any employee related operations, we are performing employee class. If any address related operations, we are performing address class. So we are not violating the single responsibility principle. We have only one reason to change. Second principle, open and close principle. Open for extension, but closed for modification. See here, I'm taken one enum type called employee type. Some enum constants I'm added. Another class employee. Here some logic I am developed. So suppose these two are the enum type. If I added another enum type called junior, then I will need to modify the code. I will need to here add another case called junior. So it is violating the open and close principle. Instead of writing like this logic, it is recommended to write take one start class employee. Suppose public class manager extends employee, public class senior extends employee. If another class junior, public class junior extends employee. So then should be open for extension. This is open for extension, closed for modification. This is closed for modification. This is the second principle saying. Third principle, let's go substitution principle. Objects of a superclass should be replaceable with objects of its subclass without affecting the correctness of the program, or child class must be able to replace with the parent class. Here, now, this is the, I'm taken one green class, public blue extends green. So I'm created one green equal to new blue. So we got the output blue. Violates Lipscomb substitution principle because color of green object is blue. Actually, green object is a green. So it is violating the Lipscomb substitution principle. Instead of writing this logic, it is recommended to take one. Instead of taking the class, it is recommended to take interface. Interface I color. Public class green implements I color. Public class blue implements I color. Then interface reference is equal to new class. You can call color.get color. This is the good practice. Fourth one, interface segregation principle. Clients should not be forced to depend on interfaces they do not use. They do not use. It promotes the idea of segregation large interfaces into smaller and more specific ones. More specific ones. See this example. So interface I artist is there. So it is doing dance, sing. So here some Raja is there, implements I artist. Raja is performing dance and sing. Okay. Shankar is there. So Shankar is not dancer. So it is not dancer, but Shankar is a singer. But Shankar is forced to implementing the dance. So instead of I artist mixing the dance and sing, it is recommended to take separate interfaces like I dancer one interface, I singer one interface. Suppose Raju is doing like dancing is known and singing is known. So I dancer, I singer. But Shankar only known singing. Then Shankar will implement sing. Here, the interface segregation principle, clients should not be forced to depend on interfaces they do not use. They do not use. Here, in this exam, bad practice, Shankar is don't know dance, but is possible to override dance method. So it is bad practice. Instead of taking it in one interface, you can take separate interfaces. So it is recommended approach. Fifth one, dependency inversion principle. Dependency inversion principle. Use interfaces or abstract classes to get implementation details, similar to auto wiring in Spring Boot. See a bad practice. Public class data access. So we are taken as a variable here. So we are injected through constructor code to create a user. Instead of like this, taking the class, take as a interface, implements data access. Yeah, it is recommended approach. It is recommended approach. Instead of taking the class, you can use the interface. You can override this method and implement. So these are the most important solid principles. These are the five. Single responsibility principle. Single responsibility principle. The single responsibility principle. A class should have only one reason to change. So it is we have two reasons to change this class. So if I add employee, this is one reason. If I add other, these are the two reasons to change this class. So it is violating single responsibility principle. It is good practice. So employee class is only one reason to change. Others class is only one reason to change. Second one, open and close principle. Open and close principle. Here, if I add any new enum type, we need to change the code. So open and close principle, it is violating. Should be open for extension, but close it for modification. Yeah, because of this, take one abstract class, public class manager extends employee. Say public class senior extends employee. If you are adding any junior, public class junior extends employee. So it is satisfying open and close principle. Should be open for extension, but close it for modification. Next principle, let's go substitution principle. What is saying? Objects of a superclass should be replaceable with objects of subclasses without affecting the correctness of the program. So here bad practice, public class green, public class blue, extends green. So here violates let's go substitution principle because color of green object is blue. So instead of taking class, you can take interface like common type iColor. You can public class green implements iColor, like public class blue implements iColor. So it is not violating its substitution principle. Interface segregation principle. Clients should not force to demand on interfaces. They do not use it. They do not it promotes the idea of segregation large interfaces into smaller and more specific ones. That means here artist is there, artist interface, Raju implements and Shankar implements. Raju know dance and sing. So it is implemented too, but Shankar don't know dance, but is forcefully overloaded this dance method. So it is violating the interface segregation principle. Instead of taking both in single interface, segregate, like separate. See here, segregate large interface into smaller. So instead of adding dance and sing in same interface, take two interfaces, one interface for dance, one interface for sing. So Raju implements two interfaces. Shankar only in sing, so it is implements sing. Dependency inversion principle. Here, public class database. Instead of taking the class, it is recommended to take interface. You can class data access implements idata access. It is recommended to implements. You can take so for type. So save data is applicable for multiple databases. So because of you can take one idata access interface, can implement and override same method. Here, this is the ARJ variable. So it is look like a auto wiring in Springboard. We are auto wiring, we are injecting through constructor injection. So we are accessing here. Thank you for watching. This is all about solid principles.